In this video, we're going to be talking about antiderivatives. This topic will be spread across two videos. In this video, we'll be addressing the first of our four learning goals. We'll start off with the definition. A function big F is called an antiderivative of f if the derivative of big F of x is f of x. That might sound like a complicated definition, but it's actually more straightforward than you think. It's a different way of referring to the relationship between functions. Up until now, we've always been focusing on the derivative of a function. The antiderivative is just the other part in that relationship. It's kind of like how you might be a son or a daughter, and then you have parents who you would refer to as a mother or father. It depends on which way you're looking at the relationship, how you refer to them. So the functions on the right in this table are derivatives of the ones on the left. The ones on the left are the antiderivatives of the ones on the right. Perhaps another way to think of antiderivatives is to ask ourselves the question, if the function I have is the derivative, what was it that came before this? When we determine the derivative of a function, there's typically only one possible derivative. So we have to ask ourselves the same question going the other way. Does each function have only one antiderivative? We can see with one example that the answer to that question is no. There is not only one antiderivative for a function, there could be infinitely many antiderivatives. Here we have some examples of functions that all have a derivative of 3x squared. So it suggests that everything in the left column is a valid antiderivative for 3x squared. In fact, if big F of x is an antiderivative of f, then you can express a general antiderivative of f by adding a constant onto the end. So 3x squared has a very basic antiderivative of x cubed, as we saw in the first table, but technically x cubed plus any other value is also an antiderivative. And so we can say a general antiderivative of 3x squared would be x cubed plus c. The great thing about antiderivatives is that there's no actual new rules to learn here. We already know them. Our derivative rules are in our formula booklet, and if we just switch the arrows here and have it go in reverse, we essentially have our antiderivative rules. We're just working backwards. The only one that's typically a little bit confusing to work with is the power rule, and so we actually go and rewrite this one. So when we used power rule before to find the derivative, we always said reduce the exponent by 1 and multiply in front by the old exponent. And now going in reverse, we're going to actually increase the exponent by 1 and divide by the new exponent. You can confirm for yourself that this is the actual antiderivative by just taking the derivative again, and you'll see that you end up with x to the n. At this point, we'll take a break to do just a little bit of practice, and then we'll actually build up to solving some more elaborate problems with antiderivatives.